Hey guys, welcome back to the lab. As I was recording this video, YouTube sent me a message to let me know that the channel had hit over 300 subscribers. This is a huge milestone for a small channel, and all of you make that possible. Thank you again for being here and taking the time to check out my presentations and restorations. As usual, questions, comments, and critiques are always welcome. They help me know what you guys would like to see and help me steer the content in a direction that's relevant for you guys, the viewers. That being said, I've started getting viewer requests for specific makes and models of gear for restorations. I'd love to be able to accommodate these requests. It's a matter of resources and being able to find the gear at a not insane price, and also sometimes being able to find the gear itself. The used market's funny that way. To that end, I've set up a Patreon page where viewers can support the channel directly. All the proceeds from the Patreon page go directly back into acquiring gear to make videos to post on YouTube. Facilitating viewer requests is just a matter of finding the right example to restore and at not an insane price. For those who are already patrons of the channel, thank you again. It is a huge help for supporting the channel and the efforts of the restorations. And for all the subscribers, thank you for being here. It really means a lot to us and helping the channel grow. Now on to the lab upgrade. Welcome back to the lab. As you guys can see on the bench, I have two pretty large pieces of equipment. This was the pretty massive capability update that I've been talking about in the comments and everything, and I was ready to ship in. I was extremely fortunate. The shippers were very kind to these two units. The boxes weren't damaged or anything like that. I have one other spectrum analyzer in the lab, and you'll forgive me for not putting it up on the bench because it is a back-breaking 90 pounds. It's gigantic. It's a HP. It's the low-frequency spectrum analyzer. So until these two units shipped in, I was stuck at 40 megahertz for spectrum analysis, which, given the frequency on this guy, 40 megahertz is pretty low. Yeah, this is what's coming to the lab. These two units got delivered this week. This guy came up, give me a chance to be available for purchase. Both of these units should be working, at least they were sold working. This one's been recently calibrated. This one hasn't been calibrated, but I have the calibration cables, and we're going to test both of these units and make sure they work here in the video. Actually, let me turn the signal generator on, just so we can generate some tones. So the reason I picked these two units, I was never anticipating getting one of these, given that this goes up to 12.8 gigahertz. The only drawback with this unit is it's a CRT. They do have a LCD display that can fill in for the CRT, but the CRT in this is still extremely healthy. The other thing that made these two units very attractive is both of these units have the tracking generator. I'm short end connectors. I'll be getting a couple of more of them in soon. This is a special connector for this unit, which will become apparent soon. This is a DC block, but this is a DC block that goes to 18 gigahertz, so don't ask. Here are a couple other DC blocks. This is an end connector DC block. This is a BNC. These both go to, this goes to 2.2 gig. This goes to 6 gig. So I'll be using those with the slower unit. So the frequencies that the lab now covers in terms of spectrum analysis, depending on which unit I use, we can go all the way from 0.1 hertz to 12.8 gigahertz with this guy. So I got to do the slow stuff on the older HP, which is fine. But I can do spectrum analysis up to 12.8 gigahertz with this guy. Never thought I would get that high. Yeah, these units were not cheap. They did cost some money, but the price was right for what they were. And especially when you see the options that were in these units, that was one of the other reasons that made them extremely attractive. This one has a tracking generator that goes up to 2.9, so I can do up to 3 gigahertz on this guy for a tracking generator, 9K to 2.9. This guy is 9K to 1.5. So why the two when this can do everything that this can do? This one has something very special that's going to allow me to learn and take risks with that I would not feel comfortable taking risks with this one, and it has to deal with the input. If I take this off, and one of the reasons why we have this massive DC block on here, you'll notice this has an input of 0 volts DC, so nothing. It'll take up plus 30 dBm, but no DC voltage on this input at all. So we have a DC block. This particular DC block is 100 megahertz to 18 gigahertz. This particular DC block is 10 megahertz to 6 gigahertz. So if I have to do anything in between, I can do, well, if I didn't have this guy and I needed to do something under 100 megahertz, I could use this DC block, because this isn't good for under 100 megahertz, but I'm going to be using this for high speed stuff anyway. Actually, while I'm rambling, I'll turn them on just so they're warming up. Haven't really turned them on yet. This came with the calibration cables. So also they are, and if you take a look at this one, the screen, that's the screen intensity all the way down. So with the screen intensity all the way down, you can still see the trace. I hear relays clicking in here, but it's performing the initial alignment, and we have spectrum. So I'm hearing relay click a lot. So system alignments, auto align is off. Okay, that was just auto alignment, so that's fine. I'm gonna let these warm up, because they have to warm up for 30 minutes before you run them through their calibration procedures. This has some cables that we need to hook up to the front end, let them run through the calibration. This will do the calibration internally. As I was waiting for them to ship in, I was pretty excited, so I was poking around in the manuals and getting familiar with the units. The reason that I'm calling the E441B or 4411B a spectrum analyzer on training wheels, or a spectrum analyzer with training wheels, is this is still the 1 watt input, but it's capable of surviving 100 volts DC. So I can make a lot of mistakes with this input. The goal is not to make mistakes, but I am human. I can make mistakes with this spectrum analyzer that would send this spectrum analyzer to the moon. So I'm going to be using this one a lot, also to save the CRT in this one. I'm going to be using this one a lot unless I need the higher frequency, then I'm going to go to this one. The other problem with that is, and the one drawback with this one is the tracking generator only goes up to 2.9, so this is not the full 12.8 gig tracking generator, so it's 12.8 gigs here, 2.9 gigs here. So that's not a problem, because actually in the 8596E line, or in the 8585 line, they didn't make a full bandwidth spectrum analyzer. This is the fastest tracking generator option they had with the unit. Also, this has some really, really nice options for my bench and some things that we have planned. This is also a well-optioned unit. We can take a look at the options if we go to System and Show System, or Show Hardware. So, as we can see, we have tracking generator control, we have the tracking generator, and this one actually has the RS-232 and parallel port option on it. So, the main reason for picking this up was full speed tracking generator for this one, which goes up to 1.5 gigahertz, and having the input that can be very abused and not die. The reason this one piqued my interest, let's see if we go to, I need to figure out how to do it on this one again. Okay, so here we go. The way you get to there, here's the menu I wanted. It's config, and then it's more, and then show options is the soft button you want. So this particular spectrum analyzer has option 4, which is the oven, 101, which is the fast ADC, 102, which is the AM/FM demodulation with TV. It has the gate, revision B of the gate. Not 100% sure what I'd use 105 for yet. I have to read the manual, figure out why that's a good idea. 130, the narrow bandwidth, and 101 or 010, which is the tracking generator. This also has HPIB in parallel. So this has serial. So this guy down here has serial. This guy up here has HPIB. That's okay. My other analog spectrum analyzer has HPIB as well. So pretty much every as long as this CALS, which we're going to find out, it's warming up right now. This is pretty much every option I would have wanted in there. So they were extremely well configured for my lab. Everything was good. So I'm very, very fortunate to have the opportunity to get these in the lab. It's also going to let us do some things that I wasn't able to do to begin with, like calibrate the SG505s, the SG502s. What else is waiting on a spectrum analyzer? The SG503, the SG504. We'll do some checks on the 8657A, which is also new to the lab. So that has a nifty option. If you guys want me to do a separate video on that, let me know. I'll do one, but it's an RF 100 kilohertz to 1.04 gigahertz frequency generator. I've got some stuff that I'm going to need that. I actually have to do some AM/FM alignments on some tuners, so those videos are coming. That'll be a very interesting video to take a look at. I'm going to actually have to unplug these, pause these, and let these cool off. I am down in a soundproof room in an undisclosed location, and it's getting kind of boomy outside. So there's a storm that's getting pretty bad, and I don't want these getting struck by lightning. So I will shut these down, let the storm pass, and then I will be back. Okay, storm's passed, and I've been just playing a little bit, seeing how slow I can make the bottom one sweep. I've got it on a full span, 1 kilohertz bandwidth, and it's a 3.75 kiloseconds sweep rate. So pretty slow. So what I'm going to do now is I'm going to run through the calibration routines on the 8596, and we'll see if that shows up any issues. Now, there's going to be 3 calibration routines for this. There's going to be frequency, amplitude, and YIG. This has a YIG tune filter in it. So when I have to do the YIG tune filter, I'll actually be using the comb out. But to start, so we have some power. Cal, amplitude, and frequency. And it's now going to go through some stuff. I won't sit here and bore you guys with it, so I'll just leave it go at the moment. But I'll bring you back when it's time for the YIG, or if there's any problems. As we can see, it says Cal all done. Press Cal store. Cal stored. Now what I need to do is use the other Cal cable, and I need to expose the comb out. And you want to be real careful with this cable. You want to kind of put the connectors in at the same speed, a little bit on one, and you really don't want to bend this cable. This is a hardline coax. All right, everything's in. So we want to cal the YIG tune filter, and we'll let that run. Okay, and there's the results of the YIG tune filter. Everything looked good, so what we're going to do is we're going to go store cal. Cal has been stored. It's a weird cable to use. Got 2 more sanity tests, which I'm going to do, and then I'm going to put the end connector on and terminate it into 50 ohm. So what we're going to do is do a confidence test. I'm going to record this one just so you guys can see what it does. And the confidence test passed, so the Spectrum Analyzer at least thinks it's fully functional, which is great news. Pop this off. Let's put the DC block back on. So we save the input. And we'll put an end connector on here real quick. And we'll terminate that into 50 ohms. So I got DC block, a N to B and C, and a 50 ohm terminator. So now what I'm going to do is, this little notch right here is just because the resolution bandwidth is high. So what I'm going to do is I'm going to go to, no, I'm going to go to, what am I going to go to? Bandwidth. Bandwidth. Here we go. And I want 1 kilohertz resolution bandwidth. So that's going to significantly slow the sweep down. But now, it's right around 3 gigahertz. So let's do sweep. Sweep time is auto. Single sweep. Actually, let me take the DC block off, see if that's doing anything. We'll just terminate this directly into 50 ohms, and we'll have it do another sweep here real quick. Sweep. Single sweep. Now, what's interesting is the BNC is only good for 4 gigahertz, so this might not be a problem. This just might be some response of the equipment. I'll need to get to truly do this, I'll need to get a 50 ohm end terminator on there. It doesn't look too bad, but if I do frequency, center frequency, 3 gigahertz, span is 1 gigahertz. And we do a sweep again. I had the resolution bandwidth set weird. That's why it said measurement uncal. So now if I sweep that again, measurements are corrected. Everything looks good. And it's using a resolution bandwidth of 3 megahertz. But if we go to, if we drop the span to 2 megahertz, we have a nice flat line. So it's just a nature of the beast with the sweep speed. So this is perfect. This is what I'd like to see, especially with a 50 ohm terminator on there. So that is wonderful. Everything is good. The unit is happy. I got to learn how to use it, as apparent from the little bit of messing around. But this unit I'm going to set in reserve for when I need it. It's going to sit with a 50 ohm terminator on it most of the time to protect the input. This thing's probably never going to leave it, the DC block. So I also may need to, I depending on how often I use these, this one's not going to be the one below it, which we're going to look at here in a second, isn't going to be a problem because the end connector, I'm going to have sacrificial end connectors on there because I'm going to use BNC quite a bit. So if the connector ever wears out, I just pop the end connector off, put a different one on there. They're $20 as opposed to the front end input of the spec end. So the 8596 is working just fine, which is wonderful news. So we'll get him turned off. I only have 2 end connectors at the moment, so I'm having to swap them between units, but here's the DC block going on the front. I'm going to label this DC block 100 megahertz to 18 gigahertz because that's what it is. But that's to remind me not to use this under 100 megahertz, or I mean, yeah, under 100 megahertz. If I need to go under 100 megahertz, I need this one because this will go to 10. But if I'm doing work under 100 megahertz, I'm going to be using the 4411 because it's well in its wheelhouse, and I don't need to worry about this guy. So let's take a look at the 4411. Okay, here is the other spectrum analyzer that landed in the lab recently. This one actually has a cal date of as much as 14. I'll have to see what the calibration is on one of these, if there is anything to open up and look at inside or do anything like that. To do the cal procedure, it's system, alignments, align now, all alignments. And done. So now we take a look, and errors. No errors in the unit whatsoever. So this guy's good to go too. Not going to open him up, but what we will do is these are Amphenol BNC connectors. I've noticed I've bought two types, and if anybody out there can explain to me the two types, I'm not 100% sure, because these have copper conductors on the center. This has a silver plated one. So both of these are Amphenols. So like this one is got a silver plated one. I have him on my signal generator, but the one thing that I noticed is one of these, I think it was this one, was only rated for 500 matings and unmatings of the connector. These were rated for until they wear out, so this didn't have a minimum rating. So I will probably be getting some more of these instead and holding this in reserve. But for right now, that's up on my HP. So we'll put this in here. We'll stick one on the tracking generator so we can use it. Now, 1.5 gigahertz is well in the range of BNC. BNC will go up to 4, depending on the connectors and everything like that. I'm going to put these back in the lid so I don't bend these. And given that this has a input protection on it, I'm going to leave it capacitively coupled, and I'm not going to use the DC blocks on here. The other spectrum analyzer that I have, the slow one, it's a little bit unique, and one of the reasons why I'm going to keep it around in the lab and keep it going is it has 1 meg ohm inputs on it. So the 3585B, it has 1 meg, 50 ohm, and 75 ohm inputs on it, depending on how you set up the front panel. These are 50 ohm inputs, so good for RF work, not necessarily good for video work, because video tends to be 75 ohm, but I'm not doing a lot of video, so this will be perfect. So what we'll do is, to make sure it works, we'll just put the terminator on it, and let's see, sweep. Let's see, bandwidth. Yeah, viewable and resolution should be the same. Resolution bandwidth will go to 3 megahertz. Our sweep time should have our sweep time is now 4 milliseconds, so let's fire off a sweep. And there's our sweep. It's more noisy because it was faster. But if I go to, let's call it 200 megahertz, so frequency 200 megahertz, span of 20 kilohertz, sweep, but we can do, when we do that, we can change our bandwidth to 1 kilohertz, and we can do a sweep, and our noise goes way down because we're sweeping. So we get our 1 kilohertz bandwidth, but it's still 275 milliseconds, but it's fast. So, given that I have my frequency generator set to 200 megahertz at a negative 10 dB negative 10 dBm signal. Let me grab a decent chunk of coax here. And there we go. So how are we on frequency? All right, so our peak's at negative 10.6 dBm. I have the frequency generator set to 200 megahertz at negative 10 dBm. And this is saying we're at 200.00040. So that's good. Let's try 100 or frequency 100 megahertz. That is now a harmonic. So if we do frequency 100, restart frequency 100 megahertz. There's the fundamental. But if we do a span of let's see, 500. Let's see, span 500 megahertz. And there's some harmonics coming out of the, let's see, marker. That's a 202. Fundamentals at 100. And then I think we have another. No, that's at 0, because that is, that's the bottom. Yeah, because then we go into negative, so we're over the span of the, so we're pushing the frequency on that end. So that's a harmonic, and then that's a harmonic. Now, one of the good things about this one, or one of the neat, measurement. Measure, that's it. So it'll give us a total harmonic distortion number of 0.47% THD at 100 megahertz out of my signal generator. So this will actually do THD measurements for us, which is also a huge benefit to the lab due to the fact that I need to measure some of the THD from the SG502s and the SG505s, so that will help us significantly in the lab. The other huge improvement that I have coming in the lab, it's not quite here yet, is I'm going to be working on a 10 megahertz reference for the lab. Now that I have the frequency counters, things like that, I'm going to be playing around with some GPS disciplined oscillators and a few other things, trying to get the trying to push the performance of the lab as far as I can with reasonable cost. You can get into some crazy setups when you get into reference oscillators and things like that, especially when you talk about rubidium and cesium and all of those fun physics packages. So, turns out both of these spectrum analyzers are working. They don't need any help, at least in the beginning. So, they're ready to get set into service. They're going to be upgrading my older BK Precision 2630. It's a rudimentary spectrum analyzer. It's nothing to write home about. Both of these HP units outclass it by far. So, real excited about getting these in the lab and getting some time on them, and continuing with the calibrations and the videos that we've been making. But that's where we're at. That's where the lab's at the moment, and some of my future plans. So let me know how I'm doing. Let me know in the comments below. If you have any suggestions, comments, concerns, I read all the comments. So let me know, and I will see you guys in the next video. Bye for now.